for today, we have our guest, uh, Gaurav Regmi from Ather Energy, where he is the product owner of uh, bo- chassis and the bodywork of Ather sco- scooter. So Ather Energy is basically a electric vehicle company based in India, which was founded back in 2013, and it has been on a rising journey since then. And so for today, the session is uh, we will start with the introduction to Gaurav Dai, and he will be presenting uh, uh, on the product development journey that every company has to go through before building an EV. And after that, we will have an interview session, and then we will take questions from the participants, and we will end the session on that note. So I would like to uh, ask Gaurav Dai to introduce himself briefly and uh, get started with the presentation. Yeah.
Yeah, thanks, Sagat. Thank you, Sagat and Team Shireto for inviting me. Initially, I was reluctant to ke banola maile and everything, but I thought, okay, I'll just share my journey. To introduce myself, I am Gaurav Regmi. I did my undergrad from Aeronautical Society of India. That was from 2007 to 11. Took a break after that, and then did my masters in aerospace structures from 2012 to 2014 in IIT Bombay. I joined General Motors right after that as a placement recruitment. Joined engine development team for some period of time. Worked briefly in Bangalore and sometime in US. Uh, so I worked there for 3 years. The job was kind of okay, but then you get this feel that you want to do something different, right? That's how you leave established company and then got that itch to join a startup. So just to give a perspective, when I was in General Motors, the team that I was working for had so I was in an engine CAE development team. So the overall team size in India was 100, in US it was another 100, and Italy, Germany, South Korea we had around a team size of 350 plus. And when I joined Ather, I was the first guy to join that CAE team way back in 2017. it, it was a different experience altogether. Within Ether, I started building teams for durability. And then NVH simulation. Then I became something called as module lead, which I'll be covering in the topic. So we have different simulation teams. One is one is durability, NVH, vehicle dynamics, system modeling, CFD and thermals, and then EMI, EMC. So I represented all of these teams as a module lead in the Ether product development journey. Then I took up parallel responsibility of being a team lead for durability and NVH also for a brief period of time. And after that, I have joined as a product owner for Chassis and Bodyworks. Now, what does product owner mean? I get this question a lot of time. During the course of my presentation, I'll try to say what does a product owner do, right? That it's a very product owner is something that you see on a software companies, not in hardware development companies. But during the course of presentation, I'll give an overview of what does a product owner do and how does the entire journey look like. So yeah, that's briefly about me. I have close to 8 years of experience in automobile industry, out of which 3 was with General Motors, and then 5 plus running now with Ather Energy. That's about me. I think most of you are from engineering, are engineering students itself, right? So
Yeah.
I can assume that very few of you have industry knowledge. So shall I go to the very basics of assuming that you guys do not know how it goes through an industry, or how shall I proceed?
Yeah. Yeah. Like, I think it is. You can start from the basics.
Cool.
Yeah.
And guys, if you have any questions in between, right, you don't have to keep quiet. I don't see faces. I just see BRS, NPPT, BG, AD, RK.
Yeah.
So if you have any questions, just stop me. If it's not a long question, we let's just try to make it more interactive. If you have any questions, just stop me. I don't mind being stopped.
Yeah.
With
Okay. I
that
will
note,
also allow the mic and the camera, which has been disabled. I will just allow the
yeah.
permission for the mic and the camera as well. Yeah, for
As
everyone.
long as guys are not in bar cheering for Argentina or France, who should
Yeah.
be fine. Let's see. I have made a very basic presentation. Can you guys see my screen?
Yes, we can say it.
Okay. So I was thinking about what do I talk in this presentation, right? And then I thought, for someone who is in their engineering college, right? You do not know what exactly happens in a company, right? How do you have an idea, and then you take that idea and then build it to a mass market product? And what are the different teams that you'll have to form? What are the different areas of work that you might be interested in, right? Initially during my college days, I used to feel only design is one area where one can work in area, but I got to know that there are a lot of areas that you can work in a company. So the topic is it could be any special, not especially EV company, it could be an automobile company as well. How do you take ideation to mass production, and what are the steps on the way, how you build a team, and what are the different steps that you do together to go to mass market is something that I'm going to cover in the next 10 minutes or so. So where does it begin from, right? There could be two scenarios. Scenario one could be some of you who is aspiring to be an entrepreneur, thinks that, okay, I want to build a certain EV vehicle, or it could be an established company which is trying to launch a new product, right? So it could be in any form, any of these two forms. But it all begins with saying that I want some high level specs, right? Okay, you say that, okay, Nepal ma, I want a bike or a scooter, let's say bike or scooter. For this topic, I'll limit myself to two-wheeler industry. You want to develop a bike or a scooter, but you do not want to get limited to driving from Kotesar to Baneswar, right? You want to have some range. So I want to develop a scooter with a range of 200 kilometers. These are just some specs. I want to have a top speed of 100 kmph. I do not want to be retarded by the speed of what a typical lead acid batteries does, right? When you are limited to some 30, 40 kmph, you do not have that ohm factor in that vehicles. So you want to develop a vehicle of 100 kmph. In terms of performance, you want to have a very high acceleration of going from 0 to 60 kmph in 4 seconds. Now you'll also define whether your vehicle needs to be comfortable. By comfort, you mean all those comfort attributes that are taken in a two-wheeler. It could be the manager level of vibrations that you see at tactile points, including your rider's easy position, your handlebar position, and then your legs position. Or you want your vehicle to be very agile, right? Very good at handling. So all of that, and then you will also want to position to say whether you want this to a mass market product, or you want this to be a premium category. So these are some of the high level specs that you set to define yourself, right? That I want to do this. You have a vision of sort to say that this is essentially what I want to build. It all begins from that point, right? Somebody aspiring to build something, right? So once you are done with that, then how do you proceed from here? Now these are our wish lists, right? That I want to do this, I want to do this, I want to do this, I want to do this. But how do you proceed from here in order to start developing a company? So first thing what you do is someone details out this specs, right? Those specs here are not really engineering specs. So you'll need to now go one level deep and then see how you are going to detail it out, right? What are the dimensions of the vehicle that are going to be? What is the wheelbase that it has to be, right? What type of tire sizing you want to have, or a wheel sizing you want to have? Do you want to have a 10-inch front and a 12-inch rear, or a 12-12, or a 12-14? There could be n number of combinations that could come in, right? Now how do you define the basic vehicle layout in the initial phase? So what you have as guiding principles are high level specs. Hey, at this point, I don't want this to monologue. Am I still audible?
Yeah, yeah.
Okay, cool. So at this point, what you have is the guide rail in the form of high level specs. So how are you going to detail it out, right? So the first thing is to say that what you have defined here is to say that I need my vehicle to be highly agile, right? Very good in handling, or highly comfortable. So okay, before even that, you want a range of 200 kilometer. Now some of you engineering heads might already be thinking, right? Okay, I need a 200 kilometer range. So I might need, I mean, this 200 kilometer first thing. Is it a real world range or is it a IDC, Indian Drive Cycle Condition, right? What comes as a 40 kilometer per liter with a asterisk? Is that kind of range? First, you will have to define that. Let's assume this is a true range, right? That you are going to get in any condition. Now, for 200 kilometer, what is the battery size that you need to build? You'll do your maths and then you'll figure out maybe close to what, 6 kilowatt hour sort of battery pack. Now, for that 6 kilowatt hour battery pack, what is the chemistry of your battery cells that you are going to use? It is going to be an MC cell. Is it going to be LFP cells? So based on that, now how are you going to decide that? It depends on a lot of factors, cost being one of them, right? Or the expertise that you have in your field. And then you said how many series and parallel combination of those cells will give me that capacity, right? Then you have a basic layout of your battery. Now how are you going to position your battery? Is it going to be in the floorboard of a scooter, let's say if we talk about a scooter, or is it going to be vertically placed just underneath your seat? So this is how your dimensioning of your vehicle kind of gets started, right? Things started rolling. The other important factor in defining your dimensions of the vehicle is your something called an ergonomic triangle. Just imagine you are riding a scooter. So between a rider's CG and then your position of your hand versus your where your foot is resting on the floorboard, that defines your ergonomic triangle. And believe me, it is ergonomic might be the last thing that we think as an engineering student, right? But this is one of the things which dictates your vehicle geometry and architecture in a big way. So you'll have to define your ergonomic triangle and then say, okay, this is how it is going to be. I want my seat height to be so certain, so that 80 or 90 percentile of my customers with a average height of 5 feet 6 inches are going to sit comfortably in that. So once you define all of that, you get some sort of prelim thing. Then you have your range. You need a 6 kilowatt hour battery, for which you need a battery pack of dimension LBH. So you need that, and hence you'll define a sort of layout of your vehicle, right? And now for your performance, you want performance in the form of acceleration. Now how are you going to get to from 0 to 40 in 4 seconds? That defines how you are going to choose your motor, power of a motor, and what kind of transmission is required. Is it going to be a chain driven? It is going to be a belt driven, right? Is it going to be a hub motor? First thing first. And then range I spoke about, and then drivability is something about how easily you can go through a hill. That seems to be a major factor for EVs, right? In the initial days, if you remember, when we had lead acid batteries coming in, drivability was a major factor. There used to be a lot of jokes in Nepal, at least, saying that if you go through a hill, then you have to push your scooter through. So these three factors determine what kind of motor sizing you want to do, what kind of transmission you want to choose, and what kind of motor you want to choose. About charging, do you want it to be a 1C charging or fast charging, 1.25 C charging? Do you want the charger to be onboard, external, right? So these are all what I'm trying to say is that once you have a spec finalized, right, then you sort of define architecture of a vehicle. It could be a mechanical architecture, which defines what kind of chassis you are going to use, what kind of frame you are going to use, what kind of suspension you are going to use. Is it going to be a monoshock towards the end? Is it going to be dual shock towards the rear side? So all of, and is it going to be a brake? When you talk about brake, now it depends on what kind of vehicle that you have positioned it for, right? If it is say a mass market scooter of sort, let's say what a Activa is right today, then you can say, okay, I can get away with having a drum brake system. But if you want to position yourself as a premium category, then you'll have to make at least a district system. Has it Does it have to be a CBS system or a ABS system? That is something that you take up in this architectural level discussions. Now, during this phase, a lot of fight goes on, right? Because engineering a product is a trade-off. It's nothing. If someone says bring me a best dimension product, you can do it. But if someone says get me a best dimension product by fitting in a tire and wheel, says that you get the highest comfort, right? Now you need to do engineering trade-offs, and this is where this phase becomes a lot more critical. Now, typically, something called as a product team or a system engineering team defines this, right? They go into details and then they say, okay, they may not be in a position to say that my wheelbase has to be 1260 or a 1310 or a 1370, right? You could do some benchmark of the category of vehicles, but this is where the product team kind of goes into defining the specs for each one of these. Now, once you sort of define the specs, you'll need teams to carry the work forward, right? So, how does the team development happens? Now, these are typically the teams uh, that lies in a company, right? You could have frames. You could have frames or mechanical peripherals, which includes your side step. It includes a grab handle or a pillion grab rail, whatever you call it. It could include your center stand. So all those mechanical components could be one team which will be doing all of the work. There could be another team which will be working on brakes, tires, and suspension. Okay, there's a common thing that I've added. There is body panels and then transmission. Now these are roughly your mechanical side of things. On your electrical side of things, you would have battery, PMS. You could have electrical peripherals, horns, switches, all those kind of stuffs. You have a motor controller. You have dashboard. If it is a dashboard, if you have seen Ather, we have a dashboard of sort, which is non-typical of a typical automobile company. And then you have different ways of power distribution, how we are going to distribute power from a battery onto all of these electrical peripherals, or how you are going to power your motor controller, and then all the harnesses. Now, these are multiple teams working on detailing out all of the concepts that you have built during the spec set. In the support function, you'll require simulation team, which will validate all the loads that are coming into the structure. You need a testing and validation team. Uh, you need so after a design team makes a concept, it gets validated through initial round of simulation. It goes for testing. Then you'll need someone to take that design to a engineer to a supplier and then get it developed. Right, that is something what a new product development team does. And then of course you have sourcing, who will find these vendors who can work with the OEM to get the parts coming in. And you also have a program management team which defines timelines, risk. I mean, once you get started on the project, that is something that you'll need to actively do. And you'll also need to have integration and system engineering team uh, which will look at the integration of all these components, right? You cannot have teams working in silos. Let's say a mechanical team does not know what a harness is going to be, but your harness really dictates how the frames has to be, or vice versa also. So you'll need an integration team to kind of do that work. Now, I'll come to this slide in a little while later. But if you see, right, a typical automobile company works in this fashion. And this is something called as vertical way of working, in which you might have a mechanical team. Under mechanical team, you have multiple teams, right? And each one of them has a deliverable to say that, okay, I need to deliver a frame for my new product, or I need to have a brake system delivered for my new product. So you have multiple tests. Just imagine having just like what is called as in our engineering college, right? We have civil engineering, we have mechanical engineering, we have all forms of engineering. Now these are vertically stacked companies, and at any given point in time, something that you do in mechanical engineering, civil engineering does not know about it, right? So that is how a typical company works, and this is called as a vertical way of working. What are the challenges in this way of working, and why automobile companies are letting go of this method and moving to a more agile way of working? I'll cover in the next two slides. So let's just take a recap, right? What did we do? We said that somebody defined a high level spec to build a vehicle of certain configuration. Then you had some team coming in which detailed out all those specifications into hardcore engineering terminologies. Then you have all these teams coming in which are building, which will take their own subsystem and then try to fit in together to develop a system. But what you need is a product development framework, right? How do you kick off your project, and then how do you take it to mass production? That is something which every company will have their own product development framework. It could have multiple stages. I have just listed for a random example. So initial phase, you have a proof of concept. You say, now you have said that I want to build a 6 kilowatt hour battery pack to deliver a range of 200 kilometer, 200 kilometer, and you need a motor of 6 kilowatt or something to deliver the acceleration that you have desired, right? Now, first thing that you need to do is you need to define a proof of concept and say that it really works for you, right? You cannot kick off a project knowing whether it really works or not works for you. And proof of concept could be in the form of a system level simulation. It could be a concept that you have physically built and then validated. but you need to have some sort of proof of concept to say that whatever you are attempted to build is really a viable product that you have made. So when you kick off a project, it could take say 2 months to actually demonstrate a project. It may not meet all the attributes that you have, that a vehicle is intended to meet, but you will still get an idea that okay, this is a viable product and I can really build on that, right? After that, what you do is that you define multiple phases in program. Now this multiple phases is dependent on the complexity of the project. If you are trying to build a car, you might need more than 18 months. If you are trying to build in a scooter for the first time, you might need more than 18 months. But if it's a company which already knows how to build a scooter, 18 months might be viable, right? So there's no hard and fast rule as in how long the each phase has to be. Just imagine this, right? So you are given a concept to build, and then you are saying that okay, in X months of time, I need to go to mass production. What are the different steps that you will take? You'll need multiple rounds of physical validation to happen. So you say each stage as a alpha, gamma, lambda. In alpha stage, now you say that okay, I want my durability attribute to be at 50%, which means that whatever durability cycle that the vehicle has to pass, at least 50% has to be a pass. Then your vehicle dynamics attribute has to meet certain specifications. So you do iterative way of working to finally go into a process where every validation cycle that you have defined for your parts, right? It has met everything. It meets all the attributes, and then you are ready to do a mass production. Now, I think most of you know this already. What you may not know is what happens once your parts are mass production ready, right? What happens after that? Assume that now you have a scooter which has like 1,000 bomb items, right? A bomb item is individual items which make up that entire scooter or your motorcycle. In that includes from a washer or rubber part. So every item is a bomb item. So you have a list of 1,000 bomb items which makes up scooters. You have given mass production go ahead for all your suppliers. It could be a casting supplier where it takes okay. I think I need to talk about this. Let's say at this point, at the end of lambda phase, now you have got all of these phases. What comes as alpha phase, gamma phase, lambda phase? They are like prototype parts. Prototype parts is something that you build in your college days, or you just make something fabricated and then it works for you, right? Or if it is a aluminum component, you get it machined from a block of metal that comes in. But when it comes to mass production parts, you should, whatever is the intended process that you really want to multiply your projects and multiply your parts, right? Let's say a frame. If you have seen a frame of a motorcycle or a scooter, most of the frame is a cast. It's a sheet metal, right? Or it's a tubular frame that you have, except for Ather, which for XYZ reasons we chose it to be an aluminum frame. If someone has a question, I can maybe answer that later why we chose an aluminum frame. But finally, if you want to get that frame right and you want to build like 100,000, 10,000 scooters in a day or a motorcycle in a day, right? You need to go to a vendor which can mass produce it, just like what the YY does, right? It mass produces YY YY noodles, for example, hundreds and thousands of YY in a day without going down on the quality. Every YY packet is the same. So how do you ensure that all your products that come out, all the parts that come out, right, they are within a certain specification that the quality does not drift? Making YY might be easier, right? It may not be, but I'm just assuming that it is easier. But to make a product which is, let's say, you have a tubular frame. Now, every time you do a welding on that tubular frame, every time the process is going to be different. It depends on what is the current that you are imparting onto your welding process. It depends on what heat you are generating onto it. So how do you make parts 1,000 a day and make quality within a certain limit? That is the challenge that comes at this stage in time. So you can get a prototype in say 1 month. Typically, a plastic part you can get it vacuum casted, or you can get it 3D printed. Stamped part, you can get it in your fabrication lab. You can just get a part, use some welding, and then do it. If it is a aluminum block, then what you can do, you can just get a block of aluminum, and then machine it to get that part. But if you need to go to a mass production, then you will have to set up that process, and that process takes time, right? Tooling, I don't know if you guys have heard about it. Tooling requires certain amount of time. If you want to do an injection molding for all your plastic parts, the tooling process typically takes like 2.5 to 3 months for just that tool to get developed. Similarly, for a casting process, the dies and then all the heat treatment and then everything, machining centers, VMCs, HMCs to be set up requires an amount of time. So at the end of lambda phase, you kind of freeze your design. This is where you get a confidence that my design in all my assumptions, everything is validated and it serves the intended process. Then you try to get these parts with the final process that you intend to be for mass production. And then when those parts really come to you, then you start validating it again. That way, what you do, you validate your design at the end of lambda phase, and at the end of all those parts coming, you validate the process also. That's how your mass production parts come into existence. It comes in, then you inspect these parts, and then you have parallelly you set up your factory operations where all these parts come in together, and then it rolls out in the form of a vehicle. Any comments, any thoughts, any questions? Am I audible? First thing.
Yeah, you are
Okay.
audible. If
Okay.
you guys have any questions, then
Any
you
thoughts?
can ask. Yeah.
So I have a question होइन नेपालीमै भन्दा नि हुन्छ होला है दाइ
हुन्छ हुन्छ जेमा
हुन्छ हुन्छ।
भन्नु।
के भन्दाखेरि नि जस्तो कि अब हामीले हुन्छ नि अब कुनै एउटा प्रोजेक्टमा काम गर्न खोजिरहेको छौँ अरे अनि वी आर हाइली एम्बिसियस होइन अनि हामीले चाहिँ भनौँ न के अरे बिल अफ मेटेरियल्सको पनि कम्प्लिट लिस्ट निकाल्यौँ अरे होइन तर हामीलाई चाहिँ कुनै एउटा पार्ट चाहिएको हुनसक्छ होइन त्यो चाहिँ भनौँ न हाम्रो क्यापेबिलिटीमा छैन म्यानुफ्याक्चरिङ गर्नको लागि अनि अनि हुन्छ नि अब हामीले चाहिँ एउटा चाइनिज म्यानुफ्याक्चररलाई अथवा भनौँ न एउटा इन्डियन म्यानुफ्याक्चररलाई चाहिँ हामीले अप्रोच गर्नुपर्ने भयो अरे त्यसलाई होइन अनि हुन्छ नि उनीहरूले चाहिँ उनीहरूको चाहिँ पहिलो हुन्छ नि अब मैले मेरो पर्सनल एक्सपिरियन्समा पनि कस्तो छ भन्दाखेरि उनीहरूले चाहिँ खासमा भाउ दिँदैन क्या सुरुमा हुन्छ नि अब उनीहरूले चाहिँ त्यो वास्तै गर्दैन होइन त्यसपछि एउटा मेसेज गर्यो होइन मेसेज गर्यो भनौँ न 100वटा मेल लेख्यो होइन उनीहरूले रिडमा छोडिदिन्छन् होइन दुई एक दुईवटा रिप्लाई दिन्छन् फेरि यो त क्वान्टिटीमा जानेवाला छैन जस्ट हुन्छ नि रिसर्च गरिरहेछन् भनेर छोडिदिन्छन् होइन अब त्यसको लागि चाहिँ हुन्छ नि अब त्यो कस्तो हुन्छ होला भनौँ न एउटा आइडियल वेमा जाँदाखेरि चाहिँ कुन तरिकाले जाँदाखेरि चाहिँ यो प्रब्लमलाई भनौँ न अलिकता अलिकता सहज बनाउन सकिन्छ कि भन्ने कुन प्रोसेसबाट जाँदाखेरि त्यस्तो होला कि भन्ने कुरो
भाइको नाम अनि भाइको ब्याकग्राउन्ड?
म निश्चल पौडेल म चाहिँ खासमा अहिले भर्खर 12th बसेँ हो तर जस यो भए तापनि मेरो इभीमा चाहिँ इन्भल्भमेन्ट थियो नास्टको प्रोजेक्टमा पनि मैले इभीमा काम गरेको थिएँ होइन अनि जस इलेक्ट्रिक भेहिकल्समा एकदमै इन्ट्रेस्ट छ
ओके सो निश्चल सी इफ तिमीसँग आफ्नो एउटा कम्पनी छ भने होइन देन फर्स्ट थिङ इज यार सी सप्लायरहरूलाई जसरी ऱ्यान्डम इमेल पठायो भने सप्लायरको पनि दे मे नट बी ओएम बट दे हेभ देयर ओन बिजनेस है मोस्ट अफ द केसेस दि सप्लायर्सहरू एकदमै ठुल्ठुलो बिजनेस हाउसहरू हुन्छ आई क्यान गिभ फ्री इक्जाम्पल्स जोसँग हामी काम गरिरहेको छौँ एउटा मदरसन भन्ने छ इट्स अ युनिकर्न राइट so all of these vendors are कुनै एउटा random email आउने बित्तिकै they may not jump into conclusion. So first thing is to have build your relationship with them. I know for you it might be difficult है तर फर्स्ट थिङ भनेको तिमीले के गर्न खोजिरहेको छौ किनभने इफ यु गो टु अ मास मार्केट सप्लायर राइट उसले के चाहन्छ भन्दाखेरि उसले कति तिमी अथवा तिम्रो कम्पनीमाथि स्पेन्ड गर्यो भने म यसको बिजनेस रिटर्न कति पाउँछु भने दे विल अलवेज ट्राई टु गेज दैट एन्ड दैट ह्यापन्स विथ अस अल्सो राइट Ather, we are almost $1 billion company now. We are valued more than $850 million. Still, हामी कतिचोटि let's say टाटा स्टिलसँग हामीले डाइरेक्ट स्टिल किन्न खोज्यो भने उनीहरूले हामीलाई भाउ दिँदैन किनभने हाम्रो पर्चेस भनेको मोर लेस देन 10 tons per month हुन्छ भने मारुति सुजुकी buys like 1 lakh tons per month है so it's a natural phenomenon. It's just that you'll have to develop a relationship with these vendors, try to say them this is what I intend to do, right? This is where I am building something and then future ma यसलाई स्केल गर्छु भनेर त्यसरी कन्फिडेन्स लिन सक्यो भने सजिलो हुन्छ नत्र भने ठुलठुलो भेन्डर नभएर सानसानो भेन्डर हुन्छ or if I give you a better suggestion, right, if you are intending to develop something manufacturing aggregator कम्पनीहरू पनि धेरैवटा छ अहिले इनफ्याक्ट I don't know if you guys have heard about it. एउटा जेटवर्क भन्ने कम्पनी छ it's a unicorn right now. It does manufacture जसले उबरले क्याब्सहरूलाई कनेक्ट गर्छ नि अथवा पठाउले बाइक्सहरूलाई कनेक्ट गर्छ नि जेटवर्क कनेक्ट्स सप्लायर बेसिस विथ द कस्टमर्स सो त्यस्तो कम्पनीबाट पनि अप्रोच गर्न सकिन्छ I know it's tricky if you are trying to build 1-2 parts supplierले त्यति भाउ नदिन सक्छ it's true but if you have a visibility that you want to scale up and then you have a viable business model then it's just about finding the right suppliers. LinkedIn बाट कनेक्सन बढाउने, त्यहाँको मान्छेसँग कनेक्ट गर्ने, उनीहरूले एउटा बिजनेस देख्नु पर्यो नि. बिजनेस देखेन भने त उनीहरूले टाइम मनी इन्भेस्टै गर्दैन. As simple as that.
हस् दाइ, थ्याङ्क यू भेरी मच. अनि
Thanks.
हुन्छ नि अब अर्को नि यसमा मैले राखेँ भनौँ न, जस्ट हजुरले त भन्नुभयो होइन, जस्तो स्टेपहरू मैले टिभी पनि राखेको छु होइन. तर जस्तो कि हुन्छ नि, जस्ट इनिसियल फर्स्ट सेकेन्ड स्टेप्सहरू चाहिँ के हुनसक्ला हुन्छ नि. अब हजुरले त इन्डस्ट्रीमा काम गरिराख्नु भएको छ होइन. यो भएदाखेरि चाहिँ अब हामी एज अ न्यू पर्सनले चाहिँ नयाँ आइडियामा काम गर्नको लागि चाहिँ यदि अप्रोच गर्नु परेको खण्डमा चाहिँ हुन्छ नि, हाम्रो फर्स्ट इनिसियल अथवा हुन्छ नि फर्स्ट सेकेन्ड स्टेप्सहरू चाहिँ के हुन्छ होला, त्यति ब्रिफली भनिदिनु न मलाई.
फर्स्ट स्टेप भन्नाले युआर तिमीले आफै कुनै एउटा प्रोडक्ट बनाउन खोज्ने कुरा गरिरहेको छौ है.
हजुर हजुर.
Okay, first thing is that you'll have to build a prototype, right? You can't. Automobile is very cash intensive business, right? Atherले अहिलेसम्म 1,000 crore भन्दा बढी budget and fundraise गरिसकेको छ, but we are still struggling to get our next round of funding. So it's a very cash intensive business. So first thing के गर्ने भन्दाखेरि एउटा viable prototype बनाउने, and then you try to get investors on board who can take that prototype into mass production. So prototype बनाउनलाई चाहिँ आफ्नै or I mean just imagine, right? तिमीसँग एउटा पुरानो एउटा एक्टिभ, if you are trying to make a bike है, कुनै एउटा existing bike को सबै कुराहरू इन्जिन निकालेर you try and fit a battery pack onto that and make a viable business, viable prototype. Once you do that, त्यसपछि roll out हुन्छ. Without having a prototype, if you just say कि मसँग idea छ, I don't think that will attract investors or supplier interest or anybody for that matter.
Yes, thank you.
Anything else? Okay, I'll move on. Hey, so we went into 3 phases. We went into saying how does it begin. I mean, having a wish list of sort. Then you go one level deep into defining engineering specs for each of the attributes that you want to meet out. Then you start building up teams. Every individual teams make their own subsystem, and then you try to fit the subsystem into a ready-made vehicle. Now the problem with this system is that, I mean, initial days Ather also worked in such system. Now 20-50 जनाको company हुँदाखेरि this is like all fine, right? एकदमै राम्रो. When I joined Ather, I mean, we are less than 120 people, so it is all good. But as you start building up teams, right now frame भित्र, I mean, Ather को frame now we have 13 components which make a frame, right? And mechanical peripherals you have another 7-8. Brake system you have this one, tires, suspension. So all of these teams, when they start to grow, right, what happens is now teams grow हुन्छ, त्यसपछि manager आउँछ, manager को माथि अर्को manager बस्छ, अर्को manager बस्छ. Then you start to work. Then there are a lot of conflict of interest that happens. Let's say तिमीलाई एउटा, you are in a frame team, you want to release a frame by next Saturday. There's a different team on transmission that also has to release something by next Saturday. But then now you have limited resources. कुनै पनि company you always have limited resources, right? It could be in the form of money, it could be in the form of other testing team or whatever. दुईजनालाई एउटा कुनै टेस्ट गरेर अथवा सिमुलेसन गरेर रिलिज गर्नुपर्ने छ. So सिमुलेसनसँग bandwidth छैन, right? So what happens is that what we realize is when you have a lot of teams and then managers, all ego kind of clash together, right? You are working in functional silos. What do I mean by that? So frame team you start saying, yeah, I'm in frame team, and then for you your Uber goal becomes releasing your frame or releasing your mechanical peripherals. It does not become about the end product, right? And this was the problem that we had in this way of working, in a vertical way of working. पहिले हामीले के गर्थ्यो, फ्रेम कम्पोनेन्टले फ्रेम रिलिज गर्नु पर्थ्यो यो डेटसम्म भन्थ्यो, तर in between we found lot of challenges because everything is not working about silos, right? Frame बनाउँदैछौ भने तिमीले बडी प्यानल्समा कस्तो माउन्टिङ पोजिसन राख्नुपर्छ, that has to be decided, right? Now body panels लाई let's say उसलाई 10 वटा माउन्टिङ फिचर चाहियो, at the end उसको केही फेल भयो बडी प्यानल्स, अनि उसले भने कि मलाई 12 वटा, मलाई एडिसनल 2टा माउन्टिङ फिचर चाहियो, बट फ्रेमको डिजाइन अलरेडी रिलिज भइसकेको छ, फ्रेम डिजाइन इज अलरेडी रिलिज्ड है. अब उसले भन्छ यार म किन गरौँ त बडी प्यानल आफै फिगर आउट गर्न कसरी गर्छस् भनेर. सो इट बिकम्स lot more complex when you start working in functional silos. So what did we do about it in Ather is we started making a cross-functional team of working, right? So rather than saying it's a frame team, we just said it's a chassis as a team, right? And then in that chassis as a team, you had different module leads. Now I'll tell you what a module lead is. So you have a design team, right? So if I come back here, so you have a design team, which is a frame mechanical peripherals. Now what we figured is that the problem is all of these people, they are working in silos and they are thinking best for the team. Nobody is thinking best for the for that particular module, right? Now if I say chassis is a module, or a body panel is a module, transmission is a module, nobody is thinking in best in terms of that one. So हामीले के गर्यो भन्दाखेरि फ्रेमको रिप्रेजेन्टेटिभ एउटा डिजाइनको एउटा रिप्रेजेन्टेटिभ ल्यायो, सिमुलेसनको रिप्रेजेन्टेटिभ ल्यायो, सोर्सिङको रिप्रेजेन्टेटिभ ल्यायो, न्यू प्रोडक्ट डेभलपमेन्ट म्यानुफ्याक्चरिङ इन्जिनियरिङको एउटा डेभलपमेन्ट एउटा रिप्रेजेन्टेटिभ ल्यायो, टेस्टिङ भ्यालिडेसनको, प्रोडक्ट क्वालिटी, सप्लाई क्वालिटी, म्यानुफ्याक्चरिङ क्वालिटी, इन्डस्ट्रियल डिजाइन, प्रोडक्ट सिस्टम इन्जिनियरिङ, यो सबैको मोड्युल लिड एउटा रिप्रेजेन्टेटिभ बनाएर एउटा हामीले क्रस फङ्सनल टिम बनायो, राइट? Now what we said is that now this cross functional team, which has a program manager attached to it. Now why you need a program manager? Because you'll have to now do a follow-up on it. You'll need to create tasks, you'll need to define objectives, and then you'll have to do follow-ups, right? Now this team is what we call as a cross-functional or agile team working, and then the head of this team is a product owner. So if I am product owner for chassis as a team, it means that within my team I have design, I have simulation, I have sourcing, I have NPD, I have testing validation, product quality. Everybody, whoever is required for me to ideate a chassis, right from ideation to take it to mass product, I have everyone within my team, right? And then I have responsibilities to define more like kati budget science, how much budget do I need or to set up to set up priorities between multiple projects. So that is what a product owner does. So right now what we have in Ather is so as a product owner, I have PnL responsibilities, which means that I, as a scooter development is a business, is a PnL head. Okay, one level deep. What is PnL? कुनै पनि अर्गनाइजेसनमा any unit that makes money is a PnL, right? एथरमा हामीले PnL 5 units मा डिवाइड गरेको छ. One is a scooter development, scooter manufacturing, charge infrastructure, software, business. So scooter development, you have two sides. You have mechanical side, you have electrical side, right? मेरो responsibility आउँछ chassis र body panels को. So मैले कति budget use गर्ने? This year budget I have close to 30 crores for chassis and bodyworks. मैले कुन मेरो budget केमा हाल्ने, कुन नयाँ product मा हाल्ने, त्यसको vendor को capacity बढाउने, नयाँ vendor मा जाने कि त्यही vendor मा रहने, all that things, right from what project I want to pick up and what project I want to deliver, is everything is on me. And in my team I have everyone who can design, simulate, source, so they all sit together. Now there's no class of egos, right? Because for all of them the end delivery is chassis and not a design. If someone fails, let's say a design fails in during your X1 phase, which is your after lambda phase, right? Then it is not the responsibility of only design engineers. I'll say the swim lane has failed, or the team has, I mean, we call that swim lane in Ather, but I say that now my team has failed. So what it does is that now we are everybody, but be aware that design team does not report to me in that functional category, right? Vertical level ma ke huncha, यो सबै team members haruko, they do not report to me. They have their own managers, right? Design को आफ्नै manager हुन्छ, simulation को आफ्नै manager हुन्छ, sourcing को आफ्नै manager हुन्छ, NPD को अर्कै manager हुन्छ. तर on a work level, their deliveries are aligned to me. I hope I was clear. This is rather confusing, but this just sets a context of how a cross-functional team works. So all this cross-functional team, they work together, right? What we do is we work in sprint form. Sprint one, I go 2 weeks per period. For a 2-week period, every Monday, every alternate Monday, I define your team le ke ma kaam garnu parcha bhanera. And then once I define that, team le afno activities garcha, and on a following Thursday, I review key progress virus and whether we are on track or not. That is how a cross-functional way of working is, and how it is different from a vertical way of working. That was about it. I think I took more than half an hour. Okay. That was all about it. If you guys have any questions or you want to take ahead, that's fine.
Yeah, thank you, Dai, for the presentation. I think one thing I wanted to mention was, can you tell more about the like OEM and like how they operate, and it's like basically an introduction to like what is OEM and what do they do?
So OEM is original equipment manufacturer, right? All those two-wheeler, four-wheeler companies that you see, Ather, Hero, Honda, TVS, they are all OEMs. So OEM, they own their design, right? But they do not produce each and every part. Just like what Apple is. Apple is an OEM, or let's say Dell. Dell is an OEM. It has its own design. It says that okay, iPhone 14 has to have so and so specs, but it is not going to make each and every component, right? Some of these components may be off the shelf available. Let's say you have a microcontroller which is easily available, or some of the parts could be you make a design, right? And then you ask a supplier to make it. Let's say usko case ma, if you have seen a motorcycle, right? The brakes ma already Brembo ko brakes huncha praya or endurance ko brake huncha. So those are something called as build to spec parts, where you give a spec and then these companies provide you that system. तर frame भनेको every frame is different from each and every manufacturer. So these are your build to print plants, right? The design is owned by the OEM, but it outsources the design to some other supplier which can provide those parts, and then you can build a vehicle out of it. So OEM भनेको just like what Apple does, just like what our TV company, let's say LG को TV ले जे गरे जस्तो अथवा Dell को laptop ले जे गरे जस्तो, that is an OEM in nutshell.
Mhm. Okay, right. So I think I- we talked about a lot of things in your presentation. अनि अब चाहिँ, so I will be asking certain questions, and then after we can get questions from the audience.
Sure.
And one of the thing that I wanted to ask was, what are the like challenges that uh, related to electric vehicle industry? Like, as you are working in the industry for past, I think, more than 5 years. So what do you think have been the major challenges that uh, Ether, maybe Ether as a company or EV industry in general face when they are building their product, and yeah, when they are setting everything? Yeah.
Okay. See, EV is a new product, right? Whenever you make a scooter, first thing that comes to your mind is कति पैसा पर्छ यसलाई, है? And EVs, they are not because in general the major cost in the EV is your battery price, the motor price, your controller price. So first thing what people do is people compare you against an Activa. In India, an Activa, and 5 years down the line, it used to cost like 78K. And the first scooter that Ather we made, you guys will be surprised what was the cost of the scooter that we made. Any guesses? I want to hear few answers. हामीले फर्स्ट प्रोडक्ट बनाएको होला कतिमा थियो होला?
एबोभ 3 लाख नै पर्यो होला भनौँ न। यो भनौँ न जस्ट सामानको कस्ट मात्रै, जस्ट पार्ट्सको बिल अफ मेटेरियल्सको कस्ट मात्रै त्योभन्दा माथि एक्सिड भयो होला भनौँ।
कति?
मोर देन 3 lakhs.
Wow, you have some insight, dude. Like 3.8 lakhs was the cost that we had built when we sold our vehicle for 1.25 lakhs, right? So that was one of the major challenge. How do you convince customer base saying here this really cost 1.5 lakh or 2 lakh rupees? And then you have barrier to technology. नयाँ टेक्नोलोजी सँग मान्छेले किन्दैन नि. If you know your product development मा मान्छेले कसरी गर्छ, इनिशियल फेजमा जब सुरुमा आइपड आएको थियो, आइपड आउने बित्तिकै कतिजना मान्छेले गरे होला? भेरी फ्यु, राइट? स्पेशली मान्छे पैसा पनि हुँदैन थियो होला, र नयाँ टेक्नोलोजीमा पिपल अलवेज हेभ एप्रिहेन्सन्स. सो एप्रिहेन्सन टुवर्ड न्युअर टेक्नोलोजी नेपालमा त अहिले पनि, र बिचमा कहिलेकाहीँ ब्याट्री फुटेको न्युज आउँछ, ब्याट्रीमा आगो लाग्यो भन्ने न्युज आइरहन्छ. आइसी इन्जिनमा त झन् कति 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 आगो लाग्छ, तर द्याट डज नट मेक न्युज, होइन? तर ब्याट्रीमा न्युज ब्याट्री फुट्ने बित्तिकै इट जस्ट ब्लोज अप. सो द्याट इज वान च्यालेन्ज. द्याट इज योर के भन्ने पर्सिबलको कुरा छ, होइन? द्याट इज वान. Now, when you are building vehicles also, अघि हाम्रो निश्चल भाइले को प्रब्लम जस्तै इभी कम्पनीलाई प्रब्लम हुन्छ. We go to any supplier base अनि हामी भन्छौँ कि यार we are building an EV company, we have this, give me parts. कसैले भावै दिँदैन. के EV? तिमीहरूको भोल्युम कति छ? महिनाको 3,000 हाम्रो त इनिशियल 3 वर्षसम्म हामीले महिनाको we did not sold more than 3,000 units. Right now we are doing close to 10,000 units a month, right? And when you sell at 3,000 units a month, Indian two-wheeler industry is like 2 million a month, 2 million a year, right? So कुनै एउटा सप्लायर छ जसले हन्डालाई पार्ट्स बेचेछ, उसले महिनाको 2 लाख त स्कुटर उसले आफ्नै मात्रै बनाउँछ, उसले हामीलाई किन एन्टरटेन गरोस् 3,000 को लागि? So that was another challenge that we had. We ended up paying huge amount of money to build our components, because the components, the suppliers were not ready to supply us at a competitive price. That is one of the reasons our initial scooter was at a very high price, right? And then there are few things with respect to requirements also. In general, automobile is a very traditional industry, right? They are used to doing certain things in a different way. Let's say you have a casting component, and then casting components is that the bare minimum that you are required to have is 5 mm. Now if you want to optimize on your weight, and then you say that I want to build a 4 mm, your supplier will say किन यो बनाउनै सकिदैन भनेर. First reaction is गर्नै सकिदैन, right? So these are some of the challenges that you have in terms of building a company. But most of the challenges are within yourself, right? As you, because no one knows. The real problem that we faced was कसैसँग ब्याकग्राउन्ड थिएन, राइट? नेपालमा अहिले कुनै पनि अटोमोबाइल कम्पनी बनाउन किन गाह्रो छ भन्दा वी डोन्ट ह्याभ मल्टिपल पिपल फ्रम मल्टिपल इन्डस्ट्रिज कमिङ इन एन्ड कन्ट्रिब्युटिङ, राइट? यु आर स्टार्टिङ फ्रम स्क्रच. हामीलाई पनि सुरुमा त्यही च्यालेन्ज थियो है. वी डिड नट नो हाउ टु बिल्ड अ इभी कम्पनी, किनभने कसैसँग एक्सपिरियन्स छैन. कोही एरोस्पेसबाट ब्याकग्राउन्डबाट आएको थियो, कोही मेकानिकल, कोही सिभिल. It's a very diverse band of people that we had assembled at Ather, right? So these are some of the challenges that I'll say. एक त भ्यालिडेसन थाहा हुँदैन थियो, कसरी भ्यालिडेट गर्ने, ब्याट्री प्याकलाई के गर्ने है. So all of these challenges they contribute when you are building grounds up. चाइनाबाट सिधै ल्याएर बेच्न थाल्यो भने त I don't think that there will be challenges, which a lot of companies do. But if you are trying to build grounds up, that is what Yatri also is trying to do. It is trying to develop things grounds up, and hence they are also struggling in some areas.
Yeah, that's very true. And त्यो च्यालेन्जेसको कुरा गर्दाखेरि लाइक जस्तै अब मेनली त्यो च्यालेन्जलाई ओभरकम गर्नलाई त मेनली अब आरएनडीकै थ्रुबाट केही आउटकम्सहरू ल्याउन पर्ने होला, विच आई गेस. एन्ड सो तपाईँको पार्टमा चाहिँ लाइक त्यो च्यालेन्जेसहरू चाहिँ मेजरली ओभरकम चाहिँ कसरी गर्नुभएको थियो होइन? अथवा इफ लाइक समन लाइक जस्तै अघि भनिरहेको थियो निश्चलले सोधिरहेको कुरा हो, त्यसै उनीहरूलाई चाहिँ वाट वुड बी योर सजेसन टु लाइक गेट स्टार्टेड इन द इभी इन्डस्ट्री होइन, or in general like to get into the domain of the EV?
Okay. Yeah, I think there has been a lot of emphasis on EV. EV ma one thing, I mean, there's a very great misconception that EV one it's a very specific industry. It's no way. I think most of the folks in this group you are all mechanical engineers, right? So EV one there's nothing specific. If you are talking about EV right now, there are two parts how you build a EV company. One is your mechanical parts, which is very much same as what you have in your typical IC engine also. जस्तै म फ्रेमको कुरा गर्दैछु, मेरो फ्रेम इभीमा जस्तो फ्रेम हुन्छ, अलमोस्ट सेम फ्रेम क्यान गो इन्टु आइसी कम्पनी, आइसी टु व्हीलर अल्सो है. ब्रेक्स इज द सेम. Yes, there are certain areas which are different. Let's say a battery pack. If you are trying to build, if you are saying EV, I'm guessing you are talking about a electromechanical components, right? Which includes your battery pack, which includes your त्यसमा पनि mechanical engineering काम छ फेरि. It's not all electrical engineering do it. In fact, हाम्रो battery team we have mostly mechanical engineering folks. So how do you develop that battery pack? त्यो सबै mechanical integration कसरी गर्ने? So EV मा खासै भन्ने हो भने 10-20% देखि बाहेक हैन, everything is something what a typical mechanical engineer does. There's nothing EV specific. I mean, I'm just calling it out, right? So there's nothing EV. It's just the automobile industry is what I'll say. Unless you want to really work in an electromechanical component, let's say a power control node or a motor controller or a battery pack or a BMS, right? This might be EV specific, but apart from that, right? What you do, let's say you are in testing team. Testing मा तिमीले vehicle dynamics गर्यो. अब vehicle dynamics त EV मा गर अथवा IC motorcycle अथवा scooter मा गर, it's the same thing. Same thing with simulation. Simulation you don't do anything EV specific unless you do a power board type of analysis अथवा EMI EMC simulation. So you'll find a lot of overlapping areas. There's nothing EV specific should be around 10-15%, which are very unique to EV industry. The rest of things are very general. You could take that knowledge from a typical IC company and then translate it to a EV company.
Uh, so, am I audible? I'm sorry for. Uh,
Yeah, you are. You are.
okay. So I think yeah, त्यो एउटा कुरा चाहिँ त्यो मैले नि like when we talk about EVs, generally people talk about batteries and motors and embedded system, right? अनि त्यो कुरामा चाहिँ तपाईँले ठ्याक्क क्लियर पारिदिनु भयो कि like there are also roles where mechanical engineers are very key to the industry.
There are more
अनि
than 80% of role which is very specific to
yeah,
mechanical engineering.
yeah,
EV specific is very
हजुर,
small.
yeah, I think त्यो पार्ट चाहिँ तपाईँले ठ्याक्क क्लियर पारिदिनु भयो. अनि त्यस बाहेक चाहिँ लाइक जस्तै नेपालको कुरा गर्ने हो भने वेन इट कम्स टु प्रडक्ट डेभलपमेन्ट त्यहाँ त्यसमा पनि न्यू प्रडक्ट डेभलपमेन्ट भनौँ त्यसमा चाहिँ वी डोन्ट सी लाइक मेनी कम्पनीज अर इन्डिभिजुअल्स हु आर वर्किङ एट द्याट लेभल होइन. जसरी लाइक इन्डियामा अहिले ग्रोथ भइरहेछ, अहिले नेपालमा भनेको यात्री मोटरसाइकल छ जसले चाहिँ ग्राउन्ड अपदेखि नै बिल्डअप गर्दैछ. तर देयर आर भेरी फ्यु अपर्च्युनिटी इन टर्म्स अफ प्रडक्ट डेभलपमेन्ट. मेनली यहाँ चाहिँ हुने काम भनेको सर्भिस ओरिएन्टेड र त्यस्तो भइरहेको हुन्छ. अनि
Right.
त्यस्तो सिनारियोमा लाइक वाट वुड यु टेल टु लाइक इन्जिनियरिङ स्टुडेन्ट्स अथवा एस्पिरेन्ट्स who want to be in the part of the product development segment, but there are very few opportunities here, as you know. So what would be your suggestion to them?
यार त्यसमा त सी नेपालमै काम पाए त सबैजनालाई गर्न रमाइलो हुन्थ्यो होला है. सो यु हेभ ओन्ली टु अप्सन्स, इदर यु बी एसोसिएटेड विथ अटोमोबाइल कम्पनी इन द फर्म अफ टेक्निसियन्स या जनरल म्यानेजर एफ स्टार्ट सेलिङ कम्पनीज. किन प्रडक्ट डेभलपमेन्ट त कहीँ हुँदै हुँदैन, यात्रीमा छ भेरी फ्यु है. In that case, yeah, you'll have to know. I don't want to say this, but if you really want to be in product development, you'll have to be outside. Eh? I mean, that's what most of the students do, right? Undergrad यहाँ गर्छ, त्यसपछि masters गर्न US जान्छ कि Canada जान्छ कि Australia जान्छ. Very few come to India. So if you do not feel like going very far off, India could be an option for you. But if you want to work in a product development company where you want to do hardcore engineering stuffs, right? It's a sad reality for all of us, eh? That I wish that's why I'm such a huge fan of and then well wisher of Asim and his team for Yatri. You know, I'm always in talks with them, giving suggestions and as in how we can do things, because I want them to succeed. I want at least 20-50 जनाले product development को experience पाओस् नेपालमा. But yeah, that's the grim reality for us.
Yeah, like, I think त्यो कुरा भइ नै हाल्यो. अनि जस्तै जस्तै त्यो अपर्च्युनिटी वाइज अलिकति कम छ भन्नुभयो. अनि त्यस्तो लाइक स्किल वाइज चाहिँ लाइक वाट डु यु थिङ्क मेकानिकल इन्जिनियरले लाइक स्किल वाइज चाहिँ कसरी डेभलप गर्न सक्छ आफैले? लाइक मेबी इट वुड बी थ्रु डिजाइन. लाइक मोस्टली त अन्डर ग्राडमा हुँदाखेरि डिजाइन मात्र छ भन्ने हुन्छ होइन. बट देयर आर अल्सो अदर पार्ट्स लाइक under simulation there is CFD and there is like structure analysis and other kind of things, right? So what do you tell to like mechanical student in general, like how can they like skill up and like really focus on themselves to grow?
Right. So I think I'll touch upon that subject, especially simulation को केसमा there is a lot of thing that simulation मा software सिक्यो भने NC सिक्यो भने अथवा यो सिक्यो भने मेरो एकदम राम्रो हुन्छ भन्ने धेरै जनासँग सोच हुन्छ हैन. I don't agree to that, because when I was manager for simulation, when I was hiring a lot of people and I did take a lot of interviews, I must have taken more than 100-200 interviews to hire 10-12 candidates within my team. I never asked a single question with respect to simulation. Right? I never did. I never asked them, तँलाई मेस गर्न आउँछ कि आउँदैन, कसरी मेस गर्छस्. My question were mostly fundamental in nature. Right? So there are two parts to this question. One, if you want to learn simulation, learn it, right? But do not say that learning simulation gives you a skill. It's just a tool, right? I'll just say it's just a tool. You'll have to sharpen your fundamental knowledges. है किन त्यो भइरहेछ त्यहाँनेरि इन्टरपोलेसन फंक्सन कसरी बन्छ इन द केस अफ एफईए और सीएफडी मा त्यो कन्ट्रोल भोल्युममा कसरी मुभ हुन्छ. So you'll have to really work on your engineering fundamentals, right? And engineering fundamental clear छ भने any interview, right? यहाँको इन्डियाको होस् बाहिरको होस् any place in the world, as long as your engineering fundamentals are clear, nobody really cares what sort of skill set or software related skill set you have. So one session would be focus on your knowledge, right? Knowledge is not the bookish knowledge. I mean, get into some project in some form. I'm very happy that you guys are trying to get into Formula Bharat, right? That is one experience. I see a lot of my colleagues coming in here from this thing, right? Formula Bharat ma participate उनीहरुको आफ्नो टिम हुन्थ्यो 3 वर्षदेखि कन्टिन्युअसली उनीहरुले यसमा काम गरे हुन्थ्यो. They do not have great mechanical engineering credentials. भनेको उनीहरुको percentage हेर्न they are just kind of normal, हैन? तर they know how to get things done because they have the experience of building something really tangible. So if possible, try to get into do some project, not just for the sake of doing project, right? It could be getting into any formula student competition or anything. That would be really great. Or I don't know, Nepal Innovation National Innovation Center ma gera kunai project garna milcha bhane do that. But getting into doing things, right, is when you differentiate yourself from an engineering guy to a physics guy, right? No offense to physics, but if you are an engineer, you have to build things, and that is how you'll differentiate yourself as an engineer.
Mhm. Yeah. So I think building is really important, and that is also what we have been trying to do for like last
Right.
2 years. अनि सो करेन्टली लाइक तपाईँले अघि भन्नुभयो फर्मुला भारतको कुरा, त्यो चाहिँ हामीले चाहिँ जस वी हेभ स्टार्टेड टु लाइक get through the research phase and get some initial designs. I think we will get there by the next month. अनि अर्को कुरामा चाहिँ लाइक जस्तै भन्नुभयो say someone here in Nepal, how could like they maybe get go to India and like be part of a company like Ather or like OEMs that have been working on in the product development segment, right? And like what would be the way for them, like so who want to work in the product development segment?
Right.
So that is the question. Yeah.
So for most of us in Nepal, right, India sometimes feels like I mean for Nepali foreigner भने treat गर्छ होला के गर्छ होला job पाउँछ पाउँदैन, right? All those things are not really true. It's very easy to come to India and work, right? I mean that is one of the reasons why I chose to be in India, because the kind of experience that you get, right, and there's no racism towards you because you look the same. होइन and then no one really differentiates कि त नेपाल I mean हामी नेपालीहरुमा एउटा हुन्छ क्या इन्डियनहरुले नेपालीलाई हेप्छ भन्ने. That's not true है. Being here for so long, I can really say that. In fact एथरमा अहिले मदेखि बाइक I was the one for a long period of time. Recently एकजना दुईजना तीनजनालाई जोइन गराएको छ to be this thing, right? दुईजना हार्डवेयर प्याकेजिङ टिममा छ, एकजना बुद्ध एयरमा काम गरिरहेको थियो, and like you said, he was not happy with what he was doing at Buddha Air, rescheduling flights and doing everything, है. अनि उसले उसको साथीको थ्रु अप्लाई गर्यो. नाउ ही इज प्रिटी ह्याप्पी हियर. अर्को एकजना छ, अनि अर्को एकजना एचआरमा पनि छ. सो मदेखि बाहेक अहिले तीनजना छ एथरमा नेपालीहरू. As long as your resume is fit, right, and once you get into Formula Bharat, it will be really easy because हामी Formula Bharatमा aggressively hire गरेर जान्छौँ. When we go there, right, we go there to participate as design judges. We evaluate students, we talk to students, and if we find some students good, we give them an offer letter then and there itself. So participating in Formula Bharat will be a really boon for you. If you guys participate and then we find you good, we will give you an offer then and there itself. Apart from that, if you think you are interested and you have relevant experience, right, just look out for career pages of respective companies. You don't have to necessarily be at Ather. There are lots of companies, right? Ather Energy Bio, Simple Energy Bio, tons and tons of companies. In fact, if any of you guys are interested and if you find a role which is suitable for you, you can send me a resume and then I can recommend you to that particular role. Don't message me saying ki yaar mero profile esto cha, suggest me a role, right? A lot of people do that. But if you think that there is a role where you are interested, all those EV companies, right? I have a lot of connections there. I can at least forward your resume and then get you an interview. Beyond interview, it all depends on how well you can do.
Yeah. I think from the I think that would be the questions from my side. And if you have like anything specific more to you, if you want to share like केही कुरा छुटाएको जस्तो लागेको भए, then you can just add on it. Then we can ask questions from the
I'll come to that
audience.
bit in the last. Let's just take any questions that our friends might
Okay, yeah,
have.
yeah,
And
so
hey, when you ask question, can you turn on your video also? If anyone is asking
yeah,
question.
okay. If you have any questions from the
I have a
audience,
lot
then
of
you can add.
questions है अब के अरे अरूहरूको क्वेसन छ भनेदेखि सुरुमा त्यो सिकाएर चाहिँ मेरो क्वेसन गर्दाखेरि चाहिँ ठिक हुन्छ होला होइन मलाई चाहिँ 5-7 मिनटै लाग्छ कि जस्तो पनि लाग्छ अलि धेरै क्वेसन्स छ दाइसँग होइन मौका पाएको बेलामा अनि के अरे एउटा क्वेसन चाहिँ हजुरलाई छ है जस्तो कि 5 मिनट मात्रै बाँकी भनेर आएको छ मिटिङ सकिन लाग्यो हो यो जुन के अरे यो सेसन
छैन, we can continue. I think as long as Gaurav Dai is
I'm available. म
ए
8 बजे आउने 8 बजे आएर बाहिर जानु फुटबल हेर्न जानु छ त्यति हो
के अरे अरूको क्वेसन सकिएपछि म मेरो क्वेसन राख्छु नि एन्डमा अलि लामै छ मेरो क्वेसन्सहरू चाहिँ
ओके ओके नि सर
अरूको कता क्वेसनै आउन जस्तो छ त के हो
मैले नै कन्टिन्यू गर्दा हुन्छ जस्तो लाग्यो अरूको क्वेसन आउँछ जस्तो चाहिँ
I
लागेन
think yeah, you can continue. Yeah. This you can continue. Yeah.
सबैभन्दा सुरुमा चाहिँ हुन्छ नि अब मैले आफैले चाहिँ म पनि यो रिसर्चको फिल्डमा चाहिँ भनौँ न पास्ट 3-4 वर्षदेखि इन्भल्भ भइसक्दाखेरि चाहिँ मैले भनौँ न के एउटा च्यालेन्ज चाहिँ ठुलो च्यालेन्ज चाहिँ के देखिरहेको छु भन्दाखेरि चाहिँ जस्तो कि अब एउटा जुन अघि डिस्कस गरेकै कुरा पनि आउँछ होइन जस्तो कि अब हामीले कुनै पार्ट्स चाहिन्छ हामीले इभन प्रोटोटाइप बिल्डअप गर्नको लागि पनि सर्टेन कुनै पार्ट्स चाहिरहेको हुन्छ नि त्यो पार्ट्स चाहिँ दिँदैन एज त सुरुमा त हामीसँग कम्पनी पनि हुँदैन नि त किनकि मोस्ट अफ द इन्जिनियरिङ स्टुडेन्ट्सहरूसँग चाहिँ सुरुमा जस्ट आउट अफ इन्ट्रेस्ट होइन अब आफ्नो गर्न खोजेको कुराले गर्दाखेरि चाहिँ गरिरहेको हुन्छन् अनि अब यो कम्पनीहरूले नगर्दाखेरि चाहिँ जस त्यसले गर्दाखेरि च्यालेन्ज हुँदो रहेछ होइन तर यदि हामीसँग चाहिँ हुन्छ नि यहीँनिर पनि चाहिँ यदि कुनै एउटा कम्पनीले चाहिँ हाम्रो आइडिया हाम्रो डिजाइनलाई चाहिँ लिएर हुन्छ नि म्यानुफ्याक्चर गरिदिनु भयो भनेदेखि चाहिँ मलाई त्यति धेरै गाह्रो जस्तो पनि लाग्दैन होइन जस्तो कि मैले इलेक्ट्रोनिक्स एम्बेडेड सिस्टममा चाहिँ काम गर्न लागेको धेरै नै भएको छैन 1.5 वर्ष जस्तो भयो होइन अब पिसिबी छ अब हुन्छ नि मैले डिजाइन गर्न सक्छु होइन यो चाइनाले म्यानुफ्याक्चर गरिदिन्छ अब अहिले इभन नेपालमै बसेर पनि मैले प्रोडक्ट डेभलपमेन्ट एम्बेडेड सिस्टममा चाहिँ प्रोडक्ट डेभलपमेन्टको कामहरू गरिरहेको छु होइन भनौँ न कस्टम पिसिबीदेखि लिएर बाँकीको कामहरू भइरहेको छ होइन यस्तै गरी चाहिँ हाम्रो इलेक्ट्रिक भेहिकलको केसमा पनि अलिकति यो च्यालेन्ज चाहिँ देखिन्छ होइन अब यसलाई चाहिँ ओभरकम गर्नको लागि जस्तो कि जिएलसी पिसिबीले मेरो पिसिबीको डिजाइन भयो भनेदेखि 10 दिनमा पठाइदिन्छ भनौँ न अलिक सहज बनाइदिएको छ यो कुराको लागि यस्तै गरी चाहिँ यदि हुन्छ नि अब यस्तै गरी चाहिँ हाम्रो यो बाँकी यो एनर्जी सिस्टममा पनि अथवा हाम्रो यो भनौँ न यो इभीको सिस्टममा पनि यदि कुनै एउटा हुन्छ नि कुनै एउटा यस्तो सिस्टम जसले चाहिँ हाम्रो यो वातावरण हुन्छ नि पार्ट्स कलेक्सन गर्नको लागि वातावरण चाहिँ अलिकता सजिलो बनाइदिनु भयो भनेदेखि चाहिँ अलिकता भनौँ न हामीलाई चाहिँ यो यसमा अगाडि बढ्नको लागि चाहिँ त्यति धेरै बेरियर हुन्छ जस्तो पनि मलाई चाहिँ लाग्दैन होइन एउटा चाहिँ यो छ यसको लागि चाहिँ अलिकता सजेसनहरू चाहिँ भनौँ न दाइसँग पनि केही छ भनेदेखि चाहिँ हाम्रो लागि पनि भनौँ न हामीले गर्न खोजिरहेको लागि पनि एकदमै ठुलो हेल्प हुने थियो हुन्छ नि यस्तै केही टुल अथवा कि एउटा यस्तो सफ्टवेयर एउटा वेबसाइट कुनै एउटा भनौँ न केही ठाउँ जसमा चाहिँ गएर हामीले हाम्रो डिजाइन भनौँ न हाम्रो डिजाइन हाम्रो रिक्वायरमेन्ट्सहरू भनौँ न सबमिट गरेर चाहिँ त्यहाँबाट रिलेटेड सप्लायर्सको कन्ट्याक्ट अथवा चाहिँ कुनै एउटा तरिकाबाट चाहिँ हामीलाई हेल्प हुने भयो भनेदेखि चाहिँ अनि हामीलाई चाहिँ यो यसमा पनि सजिलो हुन्थ्यो होला होइन यसको लागि चाहिँ यो यसको चाहिँ केही छ भनेदेखि दाइले अहिले एड गरिदिनु होला होइन अनि त्यसपछि सेकेन्ड क्वेसन भनेको चाहिँ सेकेन्ड क्वेसन चाहिँ लाइक यो सबैको दिमागमा हुन्छ होला होइन तर जस नआएको मात्रै हो के छ भन्दाखेरि जस्तो कि अब हजुरहरूले चाहिँ एथर भनौँ न एथर इलेक्ट्रिक स्कुटर बनाउनु भयो र त्यसको एउटा एमआरपीमा चाहिँ बाहिर राख्नुभयो होइन तर त्यो गर्दाखेरि भनेको त भनौँ न एउटा कस्ट भनेको त हाम्रो टोटल सामानको कस्ट हुने बिल अफ मेटेरियल्स हुने भयो होइन सेकेन्ड कस्ट भनेको हाम्रो एसेम्ब्ली कस्टहरू हुने भयो अब थर्ड कस्ट भनेको चाहिँ अब हाम्रो अब त्यसैमा लाग्ने डेभलपमेन्टल कस्टहरू हुन्छ नि अब डेभलपमेन्टल कस्टहरू भयो सफ्टवेयरको कस्टहरू भयो होइन इभन एथरमा भनेको त त्यसमा त अब कम्प्लिट ड्यासबोर्ड छ त्यसको लागि भनौँ त्यसको सफ्टवेयर डेभलपमेन्ट अथवा त्यसको हार्डवेयर डेभलपमेन्टको छुट्टै कस्टहरू इन्भल्भ भएको छ त्यही माथिबाट अर्को रिसर्च कस्ट पनि छ होइन जस्तो कि अब इभन जस्ट 10जना इन्जिनियर जसले चाहिँ एनआरपी 50,000कै स्यालेरी खाइरहेछ भनेदेखि मन्थली 5 लाख रुपियाँ हुन्छ अनि भनौँ न जस्ट 10 महिनाकै हाम्रो रिसर्च पिरियड छ भनेदेखि पनि झन् 50 लाख रुपियाँ जतिको त हाम्रो रिसर्चको कस्टहरू इन्भल्भ भइरहेको हुन्छ होइन त्योभन्दा बाहेक पनि हाम्रो फ्याक्ट्री सेटअपको कस्टहरू त्यहाँनिर भनौँ न वर्कफोर्सलाई त्यहाँनिर चलाउनेको कस्टहरू गर्दाखेरि हाम्रो एकदमै धेरै कस्ट इन्भल्भ भइरहेको छ नि त भनौँ न हाम्रो बिल अफ मेटेरियल्स चाहिँ भनौँ न लेट्स सपोज 1 लाख रुपियाँको मात्रै आयो अरे भनेदेखि पनि यो सबै कस्टहरू एडअप गर्दाखेरि चाहिँ हाम्रो बाइकको कस्ट त 2 लाख 3 लाख 4 लाख पनि हुन्छ नि त्यो पनि एक्सिड गर्न सक्ने खालको हुन्छ नि त होइन। यो गर्दाखेरि चाहिँ अब सुइटेबल प्राइसिङ चाहिँ स्ट्राटेजी चाहिँ के हुन्छ यसको लागि हुन्छ नि। अब हामीले चाहिँ अब बिल अफ मेटेरियल्सको कस्ट पनि निकाल्नै पऱ्यो, एसेम्बली कस्टको पनि केही न यसमा इन्क्लुड गर्नै पऱ्यो। हामीले फ्याक्ट्री सेटअप गरेको छ भनेदेखि त्यसको कस्ट पनि केही न केही त अब हामीले प्रोडक्टबाटै निकाल्नै पऱ्यो होइन। त्यो गर्दाखेरि चाहिँ एउटा स्ट्राटेजी चाहिँ के हुन्छ यो प्रोडक्ट प्राइसिङको चाहिँ भनौँ न एउटा त्यो खालको चाहिँ के कस्तो हुन्छ, यो चाहिँ मेरो सेकेन्ड क्वेसन हो। अनि यति नै मेरो क्वेसन छ।
Okay. Second question so I mean you are right, apart from bill of material cost, so other cost like conversion cost one sir, your the cost to convert your raw material into a finished product. This one logistics also, logistics is a huge part of the cost, right? This you'll have to know start overhead cost also, manufacturing cost also, R&D cost also, company entire cost also. This specially you'll have to give some margin to your suppliers. त्यो सबै गरेर you need to make some money, त्यो मनीमा गभर्नमेन्टलाई ट्याक्स दिनु पर्यो, and then finally you make profit after tax, है। Now to give a perspective, इन्डियामा अथवा वर्ल्डमै पनि इभन जेनरल मोटर्सको प्रफिट आफ्टर ट्याक्स दे कल इज अर्निङ्स बिफोर इन्ट्रेस्ट अमोर्टाइजेसन एन्ड ट्याक्स इबिटा भन्छ है। इट्स अराउन्ड 8 to 10%. A good company like Bajaj does it at 18%. So you need to have now all this. The most important thing that's why automobile industry is called a mass production is that now you'll have to sell maximum number of vehicles. If you sell only 100 vehicles, किनभने यो capex cost is your capital investment that you need to make. एउटा फ्याक्ट्री बनाउनै पर्यो, फ्याक्ट्री बनाउन करोडौं लाग्ला है। त्यो करोड लागेको फ्याक्ट्रीबाट 50 वटा मात्रै मोटरसाइकल लन्च गर्यो भने त 1 करोड डिवाइड बाइ 50 इज योर कस्ट, त्यो पर कस्टमा जाने भयो। And that is precisely the reason नेपालमा अहिलेसम्म नेपालको बिजनेसम्यानहरुले नेपालमा प्रोडक्सन गर्न नगरेर खोजेको कारणै यही हो। किनभने इन्डियाबाट ल्याएको गाडी अथवा चाइनाबाट ल्याएको गाडी बाहिरबाट ल्याएको गाडीमा 40% सिधै मार्जिन खान पाउँछ भने यहाँ कसले दुःख गर्ने। So it's an economy of scale, है। So until and unless you reach a certain number, beyond that all your entire manufacturing proposition does not look very viable, right? So there's no magic formula to it. As long as you say, okay, if I talk about Ather, right, we are right about hitting, getting to a point of profit. We have sold around 1 lakh scooters, not 1 lakh, 75,000 this financial year. We are on track to sell more than 1 lakh, 1.3 for this annum. And even at that volume, we are still not profitable yet. Okay? So it's just about economy of scale. So if you launch a product in Nepal, kati wala besne, so to have all of this cost accounted for, and you still make some money, right? That is the math that you need. There's no magic formula to it. But
यसमा अझै एउटा फलो क्वेसन मैले राखौँ जस्तो कि होइन, अब भनौँ न सुरुमा भनौँ न फर्स्टमा हजुरको कम्पनी इस्टाब्लिस भएको भनौँ न 8 वर्ष 10 वर्षै भइसक्यो टाइम होइन। अब हजुरले इनिसियल फर्स्ट 5-6 इयर्स भनौँ न, फर्स्टको अथवा फर्स्ट सेकेन्ड इयरमा अथवा थर्ड इयरमा चाहिँ हजुरहरूले एकैचोटि त भनौँ न 10,000 वटा अथवा 20,000 वटा 50 वटा बाइक त सेल गर्नु भएन होला नि त होइन। त्यो क्वान्टिटी त सुरुमा त कमै थियो होला होइन, त्यो भने म आई विल अज्युम है। अनि त्यो गर्दाखेरि चाहिँ जस्तो कि त्यो कन्डिसनमा भनेको त हामीले अब हाम्रो इकोनोमिक स्केल आइसक्यो हुँदैन होइन। अनि जस्तै कतिपय कम्पोनेन्ट्सहरू जस्तो कि हाम्रो ब्याट्री कम्पोनेन्ट्सहरू होला होइन, जस्तै मोटर कम्पोनेन्ट्सहरू होला, जसमा चाहिँ इकोनोमिक स्केलको बेनिफिट हुन सक्थ्यो होला हुन्छ नि। 1000 पिस बनाउँदाखेरि अथवा 2000 पिस बनाउँदाखेरि इकोनोमिक स्केलको बेनिफिट हुन सक्थ्यो होला। तर त्यो हुन्छ नि गेट नट एचिभ भनौँ न। अब हामी चाहिँ डेभलपमेन्ट फेजमा छौँ, हामीले अहिले 10,000 बाइक बिक्री गरिसकेका छैनौँ, जस्ट 100 वटा मात्रै हामी बिक्री गर्दैछौँ भनेदेखि त्यतिखेर त कस्ट हाम्रो धेरै आउँछ नि त पर बाइकमा होइन। अनि फेरि हामीले बाइक बनायो भने 10 लाख रुपियाँ प्राइस राख्यौँ भनेदेखि पनि अब कसैले किन्दैन फेरि त्यो बाइक। त्यो केसमा यस्तो केसमा चाहिँ भनौँ न हाम्रो प्राइसिङको स्ट्राटेजी चाहिँ मेन बुझ्न खोजेको कुरा चाहिँ मैले यो त्यो रेन्जमा कि भनौँ न हामी पुरै फुल स्केल पनि गइसकेका छैनौँ, तर हामी एउटा प्रोटाइपबाट बनाइसक्यौँ। अब प्रोटाइपबाट चाहिँ हामी बिस्तारै अब रोल आउट हुने खालको प्लानिङ गर्दैछौँ होइन। तर फुल अन हामी फुल स्केलमा पनि गइसकेका छैनौँ। त्यो बिचको स्केलमा चाहिँ हाम्रो प्राइसिङ स्ट्राटेजी चाहिँ के हिसाबको चाहिँ हुन्छ, के हिसाबको राख्दाखेरि चाहिँ हामीलाई हुन्छ नि अलिकति अगाडि बढ्नमा मद्दत हुन्छ भन्ने कुरो चाहिँ मेन क्वेसन चाहिँ त्यही हो।
That's why you need to have deep pockets, right? That's what Ola is doing right now because it is backed by SoftBank. That's why Yatri has not been able to sell a lot of more motorcycles because there's not much of money available, right? Ather initial days, like I said, right, 3.8 lakh scooter, 1.25 so for every scooter that we sell, we are making a loss of around like how much 2.7 or something, right? So you need to have deep pockets. So there are two things, right? See, it's a curve where you need to sell to get to a point where you can sell at profit. If you do not sell, and you won't make money or you won't even lose money. So it's a business, it's a chicken and egg situation, right? That's why India ma Maruti le pani manufacturing gardakheri they had to do with Japanese and then Indian government ko support ko sath, right? That is where Hulas Motors थियो नेपालमा. I don't know if you guys know it. Sorry, Hulas के थियो हाम्रो विराटनगरमा एउटा कार कम्पनी थियो.
उल्लास नै हो.
उल्लास नै है, बाबुराम भट्टराईले चलाएको.
मुस्ताङ भनेर
मुस्ताङ
राखेको थियो.
राइट. उल्लासको मुस्ताङ भन्ने ब्रान्ड थियो. That is precisely the reason that they failed, right? They had a product, right? It was a BS2 product. Government le time diena to migrate to BS4. But precisely the reason why it failed is first thing Nepali le बनाउने भन्ने बित्तिकै हामी नेपाली बनाएको चामल पनि खादैन. हामीले इन्डियाको लामो लामो सीता भएकै भातै मन पर्छ, है? So it's just that if you are not able to sell at those higher numbers, your cost structure is not very competitive. And if your cost is not competitive and you make a inferior product at a higher cost, nobody is going to buy you. And that is precisely the reason why we do not have our automobile company yet in Nepal. It might seem very easy to say यार किन छैन नेपालमा बनाए त चल्छ नि भनेर गफ हान्न सकिन्छ हैन, but these are precisely the reasons, right? Until and unless you have a good product with a good product market fit, and then you really sell at that volume and then be price competitive with Indian or Chinese products, it's very difficult to sustain in Nepal. That's the reality. फर्स्ट क्वेसनमा देयर आर दिस थिङ सर्टन कम्पनी जेटवर्क भन्ने एउटा छ, अर्को एउटा कारखाना भन्ने चाहिँ छ मुम्बई बेस्ड कारखाना.io. आई थिङ्क हाम्रो एउटा कलिगको वाइफले खोलेको, एन्ड आई थिङ्क इट इज अल्सो डुइङ रियली गुड. सो दिज आर सम अफ द एग्रिगेटर्स. एउटा अर्को फ्रिगेट भन्ने छ, FRIGATE भन्ने. सो दिज आर सम अफ द एग्रिगेटर्स वेयर you might be able to upload your design and then get supplier bases who are interested, as long as you have a decent volume. You cannot say just एउटा पार्ट ल्याउनको लागि हैन. But these are some of the companies. You can search aggregators or sorry. But more than India, I think China ma त्यो बेसहरु एकदम राम्रो छ होला. The manufacturing base in China is really strong. So Chinese company might be able to provide you. I have few contacts of Chinese companies. If you are looking for some parts specific, right? Connect with me on LinkedIn. I'll send you those links. Okay, so
thank you very much. Just most of the questions हरुको चाहिँ भनौं न अब एउटा एक्सपर्टिजकोबाट सुन्न पाउँदा चाहिँ धेरै खुसी लाग्यो. Just thank you very much.
Thank you.
Like I think Nishal, can you like share a little bit about like what you are like currently working on? One interesting लाग्यो. I think if other guys have any questions, then we can have them. But like, can you like just briefly share in 1 minute?
एकदम ब्रिफली भन्नुपर्दाखेरि चाहिँ अब अहिले एकदम रिसेन्टली भन्नुपर्दाखेरि चाहिँ अब म जे नि गरिरहेको छु भन्नुपर्छ. अहिलेको केसमा चाहिँ हुन्छ नि आइएम वर्किङ अन द ड्रोन्स हैन. ड्रोन्समा पनि अब हेक्साकप्टरतिर अथवा भिटोलतिर भनौँ ड्रोन टेक्नोलोजीमा चाहिँ एकदम राम्रो पकड छ भनौँ न. हाम्रो टिमले चाहिँ अब ड्रोनहरुमा पनि राम्रो काम गरेर आएको छ, अटोनोमस ड्रोनहरुमा. अनि त्यो एउटा सेक्सनको थियो. अब त्यसपछि अर्को भनेको चाहिँ अब अलिकता भनौँ न फाइनान्शियली चाहिँ मैले एड गर्न जस्तै मैले अघि भनिहालेँ हैन. सर्किट डिजाइनहरु यहीँको कस्टमरहरुलाई जुन हाम्रो नेपाली मार्केटकै कस्टमरहरुलाई चाहिँ जसलाई एकदम हार्डवेयरमा चाहिँ गर्नु परेछ डिजाइन भनौँ न, हार्डवेयर कुनै प्रोडक्ट चाहिएको छ उहाँहरुको लागि चाहिँ मैले अब भनौँ न एम्बेडेड सिस्टममा चाहिँ अब सर्किट डिजाइनदेखि लिएर कोडिङदेखि लिएर ए टु जेड कामहरु भनौँ न त्यस्तो गरिदिरहेको छु हैन. अनि त्योभन्दा बाहेक चाहिँ अब मेरो एकदम बच्चैदेखिको भनौँ न चाहना भनेको चाहिँ बिल्डिङमा इभी थियो हैन. इभी टु व्हिलर थियो. मैले बनाए पनि मैले हुन्छ नि म 8 क्लासमा हुँदाखेरि मैले मेरो बनाएको इलेक्ट्रिक स्कुटरबाट चाहिँ म इलेक्ट्रिक साइकल स्कुटर पनि हिँड्छ एकदम त्यो सबैको पार्ट्स थियो. रिक्साको पनि पार्ट्स थियो, साइकलको के पार्ट्सहरु मिलाएर चाहिँ मैले इलेक्ट्रिक स्कुटर बनाएको थिएँ. अनि त्यसबाट म कलेज स्कुल पनि जान्थेँ हैन. 8 9 हुँदासम्म म 2 वर्ष आफूले बनाएको स्कुटरमा पनि गएँ. अनि अब अहिले आइराख्दाखेरि चाहिँ अब जहाँनेरि भनौँ न अलिकता पैसा पनि मैले कलेक्सन गर्न सक्छु जस्तो लागिसकेपछिबाट चाहिँ अहिलेको लागि चाहिँ म एकदम एउटा इभी चाहिँ म बनाउँछु भने जस्तो चाहिँ छ एज अ पर्सनल हबी जसरी चाहिँ. अनि त्यसैमा म पनि भनौँ न अब यो पास्ट 4-5 महिनादेखि म पनि यो विषयहरुमा चाहिँ एकदम एक्सटेन्सिभली रिसर्चहरु गरिरहेको छु. रिसर्च गर्ने, भेन्डर्सहरुसँग सप्लायर्सहरुसँग कनेक्ट गर्ने, कन्ट्याक्ट गर्ने, पार्ट्सहरु सोर्सिङ गर्ने, एकदम खालको चाहिँ अहिले गरिरहेको छु भने एकदम एज अ आफ्नो पर्सनल हबीको जसरी. अब भन्नु पर्दाखेरि चाहिँ मैले भर्खर 12th दिएर एज एकाडेमीको कुरा गर्ने भनेदेखि चाहिँ मैले भर्खर 12th दिएर बसे हो हैन. अब मैले 1 वर्ष ग्याप लिएँ. नभएदेखि मैले यो वर्ष चाहिँ फुल चाहिँ इन्रोल गरेँ भनेदेखि हुन्थ्यो होला हैन. तर मैले यो वर्ष फेरि ग्याप लिएर चाहिँ 1 वर्ष चाहिँ मैले बाइकमा गर्छु भनेर चाहिँ बसेको छु. अब त्यही नै हो.
Okay. think
Congratulations to you.
Thank you.
And all the best.
Thank you.
so. अब चाहिँ like from the audience, if you guys have any questions, then we will take it. Otherwise, we will have to close the session in few minutes. Yeah.
सबैजना फुटबलको मुडमा छ आज।
हुन सक्छ।
यो एउटा क्वेशन सोध्छु है मैले।
Yeah.
सुन्नु भइरहेछ है?
Who's this?
म चाहिँ भुवन घिमिरे, अहिले अटोमोबाइल इन्जिनियर थर्ड इयर इन्जिनियरिङमा थर्ड इयरमा छु।
Okay.
यो तपाईले फ्रेम डिजाइनिङको फ्रेममा काम गर्नुहुन्छ भन्नुभयो, फ्रेम फिल्डमा हैन?
हजुर।
तपाईले यो डिजाइनिङ गर्दाखेरि चाहिँ फर्स्टमा केबाट सुरु गर्नुहुन्छ के तपाईले? जस्तो कि त्यो लोड एनालाइसिस गर्नुहुन्छ कि मटेरियल सिलेक्सन गर्नुहुन्छ कि हैन? त्यो एउटा प्रोसिजर चाहिँ के हो हैन?
Okay.
हो त्यसको बारेमा हामी अलिकति भनिदिनु न।
Okay. So first architecture fix हुन्छ है। once you finalize your architecture, तिमीले भन्न खोज्यौ कि मैले एउटा फ्रेम बनाउनु पर्ने छ, त्यो ट्युबुलर फ्रेम हुन्छ कि एल्युमिनियम फ्रेम हुन्छ, राइट? have you guys seen Ather को फ्रेम कसैले? by the way, it's very different. A traditional scooter to motorcycle has a tubular frame. We chose to have aluminum frame. That is for a very specific reason, and I want to add that to this answer. हामीले के गर्यो भन्दा सुरुमा फर्म फ्याक्टर डिफाइन गर्यो कि एथरको स्कुटर यस्तो देखिनुपर्छ भनेर। इफ यु गाइज हैव सीन एथर स्कुटर हैन, इट लुक्स भेरी डिफरेंट देन अ एक्टिभा और अ डिओ और अ वेस्पा और एनी अदर स्कुटर्स। सो त्यो फर्म फ्याक्टर सुरुमा डिफाइन गर्यो, त्यसपछि त्यसको भित्र चाहिँ हामीले फ्रेम फिट गर्न खोज्यो। अनि त्यो फ्रेम फिट गर्न खोज्दाखेरि ट्युबुलर फ्रेम वाज भेरी डिफिकल्ट बिकज you might know tubular frame ma tolerances are ekdamai high huncha. One of the things mechanical engineer you need to know is your tolerances, right? So to tolerance level ma we are never able to fit the existing correct. So if you see the frame here, right, the pasadi ko motor dekhi mathi rear frame bhancha hami त्यसलाई. There are 5 different parts which makes a rear frame. Ulle motor ma le arrow देखेरा छ, त्यो सबै aluminum frame goes LHRH rear bottom front 5 वटा कम्पोनेन्टले rear frame हुन्छ, mid frame 3 वटा हुन्छ। यो हाम्रो Gen 1 को स्कुटर हो, अनबोर्ड चार्जर हो, अगाडिपट्टिको त्यो हेड सक हुने एउटा ट्युबुलर स्ट्रक्चरमा हो। So once you define an architecture, right, especially you start saying ki whether it has to be aluminum or whether it has to be a sheet metal or a fabricated structure or a tubular structure, right? Hamro kesma for different reasons we chose aluminum. That's why we end up making a very expensive frame. We made lightweight, but we end up making very expensive frame. But let's say you decide to make it a tubular frame. You go by convention route, right? So once you decide to do that, त्यसपछि तिमीले फर्स्ट कुरा के गर्ने भन्दाखेरि तिम्रो डिजाइन भोल्युम फिक्स गर्ने हो। तिम्रो यदि स्कुटर हो भने स्कुटरको लेआउट स्ट्रक्चरमा अगाडिपट्टि एउटा मेम्बर आउनु पर्यो, पछाडी एउटा मेम्बर आउनु पर्यो, त्यसले ब्याट्रीलाई होल्ड गर्नु पर्यो, त्यसले मोटरलाई होल्ड गर्नु पर्यो। सो वन्स यु डिफाइन योर ओरिजिनल लेआउट हैन, लेआउट पछाडी त्यसले के लोड लिन सक्छ त अब है, भेहिकल लेभलको इन्टायर लोड लिनु पर्यो। भेहिकल लेभलको इन्टायर लोड भन्दाखेरि राइडरको वेट हुने भयो, पिलियनको वेट हुने भयो, त्यसले 30,000 किलोमिटर 50,000 किलोमिटर 1 लाख किलोमिटर इन डिफरेन्ट रोड कन्डिसन्स त्यो लोडले लिन सक्नुपर्ने भयो। एउटा 20-25 किलोको ब्याट्री वेटलाई त्यसले थाम्न सक्नुपर्ने भयो। त्यस पछाडी देयर आर मल्टिपल लोड्स दैट कम इन योर भेहिकल। त्यो सबै लोडहरूलाई, सो इफ आई जस्ट आन्सर योर क्वेसन इन ब्रिफ हैन, फर्स्ट थिङ इज डिफाइन योर डाइमेन्सन अफ योर फ्रेम, कस्तो हुनेवाला छ, कहाँ त्यसको हार्ड पोइन्टहरू कहाँ हुनेवाला छ। वन्स यु डिफाइन दैट देन यु चुज योर मटेरियल। यो ट्युबुलर हुनेवाला छ कि फ्याब्रिकेटेड हुनेवाला छ कि एल्युमिनियम हुनेवाला छ कि। वन्स यु डु दैट यु स्टार्ट डिटेलिङ इट आउट। कार्ड बनाउँछौ तिमीले इनिशियल कन्सेप्ट्स। वन्स यु मेक यो इनिशियल कन्सेप्ट, त्यसपछि तिमीले त्यसलाई प्याकेजिङ स्टडी भन्छ। तिम्रो त्यो जुन भोल्युम छ नि, डिजाइन भोल्युम, यु डु नट ह्याभ इन्फाइनाइट डिजाइन भोल्युम, यु ह्याभ अ लिमिटेड डिजाइन स्पेस। एउटा 4 आनामा घर बनाए जस्तै हो क्या, जतिसुकै घर बनायो भने ती फिट त तिमी गर्नुपर्छ है। सो त्यो डिजाइन स्पेसमा वन्स यु फिट एभ्रिथिङ, then you start going into details of your load ele tham saksai sakdaina. There you start doing your initial analytical calculation. You could do a basic shear force bending moment diagram and then figure out whether everything is okay or not, whether you need to increase the size of your tube, whether you need to increase thickness of your tube, right? त्यस पछाडि चाहिँ सिमुलेसन गर्न सकिन्छ अनि त्यसपछि इभेन्चुअली भ्यालिडेसन गर्ने हो. भ्यालिडेसन इज लाइक वन्स यु मेक अ प्रोटोटाइप इट हेज टु गो थ्रु भ्यालिडेसन एन्ड देन रियली भ्यालिडेट योर assumptions. But if I list down in stage of 1 to 3, first is to find out what is the packaging space that is available to you, because you do not have infinite space available for you. You'll have to figure out battery कहाँ हुन्छ, motor कहाँ हुन्छ, swing arm कहाँ हुन्छ, handlebar कहाँ हुन्छ, caster angle कति हो. Once you define everything, you form a basic layout of your frame. त्यसपछि कुन मटेरियल चुज गर्ने, it depends on manufacturability. यदि वर्षको 10,000 वटा मात्रै बनाउने एकदम निश स्कुटर बनाउने अथवा निश मोटरसाइकल बनाउने हो भने you do not go for a high end highly manufacturable process, हैन. त्यो बेलामा एल्युमिनियम बनाए पनि भयो. Ather was supposed to be that. It was not supposed to be 1.5 lakh 4 lakh per annum vehicle. That's why we went with aluminum. But if you want to go for a mass production, then it has to be a tubular frame. Tubular frame मा कसरी बेन्ड गर्ने, कति लोड लाग्छ, त्यसपछि it all follows. Did I answer your question in some form? I feel confusing.
हजुर ठीक भयो हजुर, धन्यवाद.
Okay, fine. Thanks.
अरू कसैको केही क्वेसन छ भने सोध्दा हुन्छ. गौरव दाई चाहिँ ठ्याक्क कति वर्षमा एभाइलेबल हुन्छ भन्नुभयो?
म अब at max another 14 minutes, 7:30 I'll leave.
Okay. So question, I think audience-बाट त्यति नै होला.
one last question है.
Okay.
जस्तो कि अब हामीले अब ट्युबलरमा भनौँ न, अब हामीले 1 to 20 प्रोटोटाइप बनाइराख्दाखेरि त हामीसँग एल्युमिनियमको अप्सन पनि छैन होइन. त्यो गरिराख्दाखेरि चाहिँ अब हामीले ट्युबलर फ्रेममै जानुपर्ने हुन्छ. ट्युबलरमा पनि अब उसो भनौँ अनलाइन स्टडी गर्दाखेरि चाहिँ अब डिओएम र त्यसपछिबाट यो के अरे इआरडब्लु, त्यसपछिबाट स्टिलहरूको भनौँ न विभिन्न खालको हुँदो रहेछ. फेरि अब कन्स्ट्रक्सन स्टिल होइन, त्यसपछिबाट अटोमोटिभमा हुने स्टिल. मेनली भनौँ न, मेनली चाहिँ के डिफ्रेन्सेस छ होइन. मेनली चाहिँ अब यो इआरडब्लु जुन नेपालमा जेनरली एभाइलेबल हुन्छ होइन, त्यसमा र एक्चुअल अटोमोटिभमा चाहिँ अब डिफ्रेन्सेस के हुन्छ, अथवा इभन कम्पनीहरूले पनि त्यही बेसिक्स नै युज गरिरहेछन् कि के कस्तो छ होइन. मेन भनेको चाहिँ यो डिओएम र इआरडब्लुको चाहिँ जस्ट भनौँ न अनलाइनमा चाहिँ त्यो मात्रै हो कि के कस्तो हो यसमा चाहिँ अलिकति एक्सप्लेन गरिदिनु. अनि अर्को भनेको चाहिँ जस्तो कि वेल्डिङको कुराहरू पनि आउँछ होइन. त्यो गर्दाखेरि वेल्डिङ अब त्यो ट्युबहरूमा चाहिँ वेल्डिङ गर्दाखेरि पनि अब वेल्डिङ गर्दा त्यो सिङ्किङ हुने होइन, त्यसपछि त्यो डिफर्म हुने खालको कुराहरू पनि हुन्छ होइन. यसमा चाहिँ कुनै अब इआरडब्लुमा अथवा डिओएममा गर्दाखेरि चाहिँ कुनमा उयो हुन्छ नि, वान बेटर देन अदर टाइपको त्यस्तो केही हुन्छ कि, अथवा यो ट्युबलर ओभरअल भनौँ न ट्युबलर डिजाइन गर्दाखेरि चाहिँ स्पेसल कन्सिडर गर्नुपर्ने कुराहरू के कस्तो हुन्छ कि मेनली अब एकदम ब्रिफली चाहिँ त्यो पोइन्ट आउट गरिदिनु न.
Okay. So it's a question of engineering trade-offs, right? When you say ERW1 or ERW2 or a CEW1 or a CEW2, there are two requirements that you have in the case of tubular frame, right? One is your strength requirements, which is dictated through what is your UTS of that particular material. I hope everybody understands what UTS is, right? UTS र yield limit उसको mechanical properties कति छ भन्ने कुरा एउटा हुन्छ. अर्को कुरा हुन्छ कार्बन कन्टेन्ट कति छ भन्ने कुरा, राइट? Higher the carbon content that you have in your material, in your steel, it has higher mechanical properties, but the caveat to that is that your weldability sort of goes down, right? So you'll have to make a trade-off between what the sweet spot that you want to hit. Let's say ERW1 could have a UTS of around 430 MPa, which should be okay, right? Because when you design a tubular frame, you are essentially designing it for life, which means that you are intending to have stresses lesser than endurance limit of that material, which could be 35% of 430, close to 130 MPa, right? But there could be some regions where, let's say a region, if you have seen a KTM frame, KTM को frame देखि पहाडी जो swing arm connected भएको हुन्छ नि, if you see that frame very carefully, the region is made of a different kind of material. It's not ERW1 or CW1. It is something called as EN80 material ले बनाया हुन्छ. किन भन्दाखेरि त्यो एरियामा लोड एकदमै बढी आउँछ. So ERW1 or CW1 cannot sustain those high loads. So you'll have to go to a material which will give you a very high UTS, somewhere to the tune of 800-900 MPa, which comes in EN80 material. So it's an engineering trade-off, right? What sort of strength do you require? If you do not require so high strength, and if your normal tubular chassis can do it, then you intend to make it with a lower carbon steel, which means that your weldability will be really good. Why do you need weldability? Because when two materials they are joined together, right, you need to have sufficient weld penetration in that region. Weld penetration it's like valley bias. Okay, I typically give this example. When you have a structural component, दुईटा मेम्बर फ्री जोइन्छ बिचमा एउटा गड्डा जस्तो बनाएको छ भने त्यो गड्डैबाट टुट्ने जहिले पनि है त्यो वेल्ड गर्ने बित्तिकै वेल्ड भएको एरिया त एकदम स्ट्रङ हुन्छ तर इमिडिएट नेक्स्ट टु वेल्ड के हुन्छ इट इज अलवेज विक पोइन्ट so it is always prone to failure and then there is a heat affected zone that comes in. So it's all engineering trade-off that you need to do. Hey, first thing is dictated through agi bhuvanle sodha jasto ma load कसरी calculate गर्ने. Once you calculate your loads हैन त्यसपछि त्यो load sustain गर्नलाई कति UTS चाहिन्छ, that you go into a back calculation, right? Then you say okay ERW1 with a 430 MPa and an endurance limit of 130 is good enough for me. You choose that material and then you start detailing out specs on their weld penetration. कति weld penetration हुनुपर्छ, कति hardness आउनुपर्छ heat affected zone मा. So these are like multi-layer deep once you go into deep of your chassis design.
One last follow-up question is यही फ्रेमको डिजाइनमा चाहिँ जस्तो कि अब हामीले चाहिँ ट्रेडिसनल बाइकहरुमा चाहिँ के देखिरहेको थियौं भन्दाखेरि चाहिँ ट्युबलर भनौं ट्युब त्यो गोलो सर्कुलर ट्युब अथवा मोरलेस भनौं न सर्कुलर टाइपको कोइलहरुमा आइरहेको थियो हैन जस्तो ड्युकदेखि लिएर ड्युकहरु अथवा इभन जुनसुकै जनरल बाइकको कुराकानी गर्दाखेरि पनि मेनली चाहिँ ट्युबलरमै आइरहेको हुन्छ हैन तर अब भनौं न एउटा रिसेन्ट ट्रेन्ड चाहिँ के पनि देखिएको छ भन्दा रिसेन्टमा चाहिँ जस्तो कि अब यात्रीले पनि युज गरेको P1 छ नि लेटेस्ट बाइकमा चाहिँ उनीहरुले चाहिँ रेक्टेंगुलर टाइपको फ्रेमहरु युज गर्दैछन् हैन अनि यस्तै गरी इभन जीरोको पनि फ्रेम जुन छ नि जीरोको त्यो अफ रोड भर्जन टाइपको फ्रेममा चाहिँ त्यो फ्रेममा पनि उनीहरुले चाहिँ यो सर्कुलरको सट्टा रेक्टेंगुलर युज गर्दैछन् हैन अब यसमा चाहिँ यदि हुन्छ नि यदि यो रेक्टेंगुलर युज गर्दाखेरि पनि बेटरै हो अथवा भनौं न हो भनेदेखि रेक्टेंगुलर गर्न त सजिलो हुन्छ कन्स्ट्रक्सन गर्न अथवा म्यानुफ्याक्चरिङ गर्न सजिलो हुन्छ हैन यो गर्दाखेरि चाहिँ के छ डिफरेन्स मेनली यो रेक्टेंगुलरको र सर्कुलरको चाहिँ भनौं न
I think rectangular one, you'll have sharp edges coming in. So circular is the best form of cross section that you can have material. The problem with cross section, circular cross section, is that it takes good amount of design space. Right? So rather than being rectangular or circular, there are certain other form factors also. Chapto halko, okay? Tela hydroform mancha. Hydroform aneko water lai entry garera tela hydroforming shape there then dina sakincha. So circular, circular is very omnipresent because it is readily available, right? It's a very optimized. It may not be the most optimum structure that is available, but circular cross section is the most optimum. That is something that you learn in your strength of materials, right? Circular cross section versus square cross section. How does it behave in torsional loads or shear strength or bending strength? But like I said, right, there's no hard and fast rule. As long as you have a design requirement or a design volume requirement where you need to have a square tube, right? And if you're confident in your design, there's nothing wrong in that. But I wouldn't go for a square tube because square tube then it's weld garna difficult huncha. Circular cross section is a lot easier. So that's why people prefer a circular cross section.
यसैमा भएको चाहिँ वान लास्ट क्वेसन है त लास्ट चाहिँ यो चाहिँ फाइनल लास्ट क्वेसन के भन्दाखेरि जस्तो कि अहिले हामीले भनौँ एउटा फ्रेम पनि डिजाइन गरिरहेको छौँ कि हैन त्यसमा चाहिँ एउटा हाम्रो कस्टम ब्याट्री प्याक चाहिँ सस्पेन्डेड हुने टाइपकोमा छ हैन त्यो एज अ स्ट्रेस कम्पोनेन्ट चाहिँ होइन तर सस्पेन्डेड हुने जस्तो स्ट्रक्चरमा छ कि हाम्रो ब्याट्री प्याक चाहिँ यसले गर्दाखेरि चाहिँ के इफेक्ट गर्छ होला हाम्रो भनौँ न यो ओभरअल भनौँ न भेहिकल डाइनामिक्समा अथवा चाहिँ भेहिकलको पर्फर्मेन्समा अथवा इभन लङ्जेभिटीमा हुन्छ नि
Suspended battery mass suspended भयो हैन
हजुर बाहिरको केसिङ भित्र ब्याट्री हामीले चाहिँ एलएफपी सेल युज गरिरहेको छौं हैन अनि त्यो सेल चाहिँ एउटा बाहिर एल्युमिनियमको हाउजिङ हुन्छ होला अब भनौं न त्यो हाउजिङमा चाहिँ पुरै वाटर टाइट हुन्छ वाटर टाइट हाउजिङ हुन्छ अनि त्यो हाउजिङ चाहिँ हामीले मेन बडीमा चाहिँ ह्याङ गर्छौं भने त्यो झुन्डाइदिन्छ भनौं न नट बोल्ट कसेर त्यसलाई झुन्डाइदिन्छ मेन बडीलाई चाहिँ त्यो गर्दाखेरि
इज इट अ क्यान्टिलिभर या फिर दुवैतिर तल माथि दुवैतिर कसने
हामीले चाहिँ जस्तो बिचतिर जुन दुईटा साइड हुन्छ नि ब्याट्रीको चारवटा साइड मध्येबाट यो दुईटा साइडमा मात्रै हामीले बोल्ट अन गर्ने हिसाबले गरेर तलबाट चाहिँ होइन जस्तो बिचको साइडतिरबाट चाहिँ बोल्ट अन गर्ने टाइपले सोचिरहेको छौँ
त्यसले एडिसनल लोड त आइहाल्छ इफ यु सी अबाउट योर लोड डिसिपेसन हैन व्हेन यु हेभ अ सस्पेन्डेड मास व्हिच गिव्स अ बेन्डिङ मोमेन्ट अन टु योर फ्रेम त्यसले एडिसनल लोड त पक्कै नै आउँछ and you'll have to check in handling attribute mapani whenever you have a lump mass which is not properly connected as a structural member telle lag dina sakcha system ma because your CG is lying somewhere there, right? So whenever you subject your vehicle to a vehicle dynamics condition, let's say you are doing a slalom or a double U-turn or whatever, all those maneuvers, right? then those launch masses could play a negative role in that you need to check.
भनेपछि सकेसम्म हाम्रो डबल अथवा ट्रिपल पोइन्ट अफ कन्ट्याक्ट हुनु पर्यो ब्याट्री प्याक डिजाइन गर्दाखेरि पनि ब्याट्री होल्डिङमा चाहिँ है
That's general principle for as long as your mass is well connected, right? It is always good from structure's point of view. Triangulate गर्नु पर्यो लोडरलाई.
थ्याङ्क यू भेरी मच
Okay.
यति नै हो तिम्रो क्वेसन के अझै आई थिङ्क यति नै हो होला
कुराकानी गर्दै जाँदाखेरि चाहिँ दिमाग फ्याट्टा 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 आइरहेको हुन्छ अनि अपर्च्युनिटी भएको बेलामा त सोधिहाल्नु पर्यो नि
निश्चलको एन्थु अनि बाकी सबजनाको साइलेन्स इट वाज इन्ट्रिगिङ आज. ठिक छ guys, thanks for listening in. I hope there is certain new information that I was able to provide you. If not, you can connect to me in LinkedIn if you have any specific questions. If you're not able to ask के सोधौँ जस्तो लागेको छ भने if you still have those questions, right, connect me on LinkedIn, send me those questions and I'll be happy or glad to answer you.
आई थिङ्क अब चाहिँ हामीले कन्क्लुड गर्नतिर लाग्नुपर्छ होला.
Right.
So like if anything you want to like still add, Gaurav Bhai, then you can add and then we can conclude the session.
Okay, China, that's about it. If you have any questions which we are not able to ask or के सोध्नु जस्तो लाग्यो ग्रुपमा सोध्न लाज लाग्ने मान्छेहरू धेरै हुन्छ नि, if you are of that kind and if you want very specific questions, you can reach out to me. I'll be happy to help. Cool guys, thank you.
Yeah, okay. I think मैले can I like drop in your LinkedIn profile so they can maybe contact you later.
Sure.
So, yeah, okay. I think मैले chat मा चाहिँ drop गरिदिएछु. If you want to reach out to Gaurav Bhai, then you can reach out to him through LinkedIn. अनि आजको लागि चाहिँ I think hopefully everyone got some insight. धेरै कुराहरू नयाँ कुराहरू सिक्न पाउनुभयो होला. अनि त्यसपछि I think we will be also conducting more session in the future. And I also hope that आजको सेसन चाहिँ सबैको लागि fruitful थियो होला. And also I would like to thank Gaurav Bhai for accepting our invitation and being the host for the today session. अनि त्यति नै हो मेरो साइडबाट. Thank you everyone. Until next time. आजको लागि चाहिँ यति नै हुन्छ. सेसन चाहिँ यही एन्ड हुन्छ. Yeah, thank you everyone.
Thank you.